Hello and welcome back. For this video, we're going to show how to solve equations that involve absolute value. You can see over here, we've got today's goal. It says solve absolute value. It says expressions. I think they meant to say equations there. If we look over here, it says how is margin of error related to absolute value? We're talking about how far over or under an expected value something could be. So that's where absolute values are actually going to be used. If we look at the learn section here, an absolute value equation contains at least one absolute value expression in it. Of course, our simplest one is this one right here, which is absolute value of x equals n. I'm going to write that off in the margin here. And one thing you want to take from this is that absolute values are distance calculations. You might want to also write that there. Okay, so you keep in mind that absolute values are distance calculations, and you calculate distances through subtraction. Now, the rest of this paragraph talks about two cases in which you have to deal with absolute value. One is a negative direction, one is a positive direction. Keeping in mind that subtraction is not commutative, meaning you can't change the direction of the numbers and still get the same answer, but the distance is still the same, so you have to consider both direction left and direction right of your current position. Now, you guys were probably taught that the absolute value is distance from zero. So I'm going to take the equation we have here and rewrite it slightly different. So I'm going to put x, absolute value of x minus 0 equals n. So remember, this is a distance calculation. So basically, n on this side represents the distance between the two values that are in here. Now, on the key concepts here, it does talk about the two cases, which means you got one where you have the positive side and one where you have the negative side. That just means to the right of 0 or to the left of 0. And again, that 0 may not actually be a 0 number. It may be a different number, but it is still to the right and to the left of that number. It's over or under. It's a distance. When we look down here, it says consider the equation absolute value of x equals 3. I'm going to write that absolute value as x minus 0 equals 3. And what we're really looking for is the distance between these two values. So the distance here is supposed to be 3. So the distance between the two in the middle is going to be 3. So if we go to 0 and we look at what numbers are 3 units away, you can see 3 units to the right is a positive 3, and 3 units to the left is a negative 3. And that's why the expression inside here can be both a positive or negative, but it will always output a positive number because distances are positive. One way that we write our answers is we go ahead and graph them like you see on the number line here. So 1, 2 answers. And another way we can do it is write it as a solution set in this format right here with the curly braces. Now, when we write them in the curly braces, we write them from smallest to biggest or numerical form. And the name of this format that we see here is called roster notation. Now, a lot of these instructions at the beginning describing how what absolute values are is a little confusing. So it's best to kind of jump into examples. So here we have example 1. Write an absolute or solve an absolute value equation where n is greater than 0. We're kind of ignore that for the moment. What we want to focus on is this equation here. And I'm going to write that again. Now remember, we're talking about distance calculations. So what we're really looking at here is the distance between y, some number, and 2, which is actually going to be a negative 2. We'll find out here in a minute. That distance will end up being 4. And for this lesson, I don't think we have to worry a whole lot about it, but at some time in the future, before we start solving these, we got to make sure the absolute value bars are by themselves. And once we do have them by themselves, like we do in this case, again, we're going to ignore this information because that's a little confusing, is we drop the absolute value, which we did here, and we set the equation equal to the positive version of what could be inside, and we set the equation again over here equal to the negative version of what could be inside. Quick little reminder. The reason that we're doing these equations here and here as equaling 4 and negative 4 is if we look at our problem again, what values could I put inside the absolute value? So if I get rid of the expression y plus 2 and I write it with a blank, what values can I put in here that could still come out to a positive 4? Well, we know that we could put a 4 in here or we could put a negative 4 inside there. In either case, the absolute value will give us 4. So in order to figure out which answer works, we take the expression that's up here and we set it equal to both the 4 and the negative 4 because our absolute values are almost always going to have two solutions. Then we just solve two equations. Key concept here, when you're solving absolute value equations, you better write two equations. If you do not write two equations, you're probably going to get it wrong. Okay, so on the left-hand side, we're going to do our regular subtract 2 from both sides. So the 2's will zero out here, giving us a y, and the 4 minus 2 gives us a 2. Now on the right-hand side, we're still going to subtract 2 from both sides, so we got a 0 here, but the difference is on the right-hand side, we're subtracting 2 from a negative 4, which is going to give us a negative 6. So our two possible solutions are 2 and negative 6. Now they do want us to write the solution set in roster form. Now remember, roster form is from smallest to biggest, so we're going to take the negative 6 and write it first, and then the 2. Now another way we can show the solutions to this is to graph them. So we're going to go graph those on the number line. We're going to graph the negative 6, which is here, and the 2, which is here. And if you remember what I said earlier, the distance between y and 2 is equal to 4, and I said it's actually not positive 2, it's actually negative 2, because remember, distances are always subtractions, and that's an addition. So if we look at the 2 points we have, the negative 6 and the positive 2 on the number line, the value that's exactly halfway between them ends up being negative 2, which is right there, negative 2. And you'll notice that the distance on either side of the negative 2 is 4 on this side and 4 on this side. And that's where our absolute values come from. Go ahead and pause the video and see if you can attempt the check. Okay, so let's go ahead and solve this. Now, first thing we got to check is see, is our absolute value by itself? Yes, it is. If it is by itself, you have to write two equations. So the two equations we're going to write, the first one is 2t minus 4 is equals, and I'm going to put the positive possibility, which is 8. And on the right-hand side, I'm going to write it again, 2t minus 4 equals. And then I'm going to put the negative possibility. So the absolute value could be an 8 or it could be a negative 8, and they both come out as a positive 8. So remember, we're looking for both of them to come out as a positive 8. So we set both equations up like this. And then we do our regular solving. So we're going to add 4 on the left-hand side to both sides, and we end up with 2t equals 12. And then we're going to divide by 2 on both sides, and we end up with t equaling 6. So we have 6 as one possible solution. This right-hand equation, we're going to still add 4 to both sides. The only difference in this output is when I add the 4 on the right-hand side, I'm adding it to a negative 8 instead of the positive 8, which was on the other side. And that's going to equal a negative 4. And then we're going to divide both sides by 2, and then t will end up equaling negative 2. So if we put this in roster notation as a solution, the solution would be negative 2, 6. Now it does say to graph the solution, so I'm going to go graph it. So I'm going to graph the negative 2 first, which is right here. And then the positive 6 will be next, so the positive 6 will be right here. Example 2 says solve an absolute value equation when n is less than 0. That means the output is going to be of the absolute value is equal to 0 or less than 0, meaning negative. So here in this problem right here, absolute values are distance calculations, and distances are never negative. So as soon as we see that the absolute value is by itself and the absolute value is equal to a negative number, you know right away that there can't be a solution. Now you can try and solve it by setting it equal to negative 1 and positive 1 and come up with a value for x. However, if you go back and check the answer with that value of x, you'll see that it actually does not work. So if we complete this, it says the absolute value of 3x minus 4 is equal to negative 1, means the distance between 3x and 4 is negative 1. Since distance cannot be negative, the solution is the empty set. So the solution set is this little circle with a line through it. It means empty set, or null set is another way you could call it, N-U-L-L. Go ahead and pause the video for a moment, see if you can complete the check. Which statement must be true for the solution? Then we have a times x plus b in absolute value is equal to c, and we want it to be no solution. So which statement causes this expression or this equation to be no solution? Well, we just said up there, absolute values can never be equal to a negative. So on this right-hand side, we have the letter C, and if that happens to be a negative number, there is no solution to this problem. So let's look down, we see letter C. says if C is negative, the solution will be empty. So choice C is our answer. Okay, for example 3, we've got more of a real-world problem where they want us to solve an absolute value equation. Well, I have a formula you might want to write down for real-world problems related to absolute value. We're talking about things that are over, under, or have tolerances in their measurements. Okay, so I'm writing that formula up here. And for most of your word problems, your general equation is going to look like this. So we've got absolute value of the actual value that's coming in minus the expected value that should be in there should equal a difference or error or tolerance. So all three of these words are kind of interchangeable for purposes of most of our word problems. So we'll see how it applies here to example 3. So on this music problem, depending on the size of each song, Luna's phone holds an average of 2,000 songs. So if we have an advertisement of this thing holding 2,000 songs, that becomes our expected value. Give or take 250 songs. So 250 could be over or under. So if we look back up here, that is a difference on this side or error or tolerance. So this is our over-under calculation. Write and solve an equation involving the absolute value to find the maximum and minimum number of songs that our phone can hold. So the maximum and minimum number of songs will differ from the average or the expected value. So average is typically expected value by 250 songs. Complete the table to write an equation that represents the maximum and minimum numbers. So the difference between the number of songs and 2,000, so the expected value, the difference between the number of, and what they should say here is the number of actual songs and 2,000 is 250. So X is the number of, they did say it down here. So X is the number of songs actually on her phone. So X is our actual value. So the equation would be actual value, which is X, minus the expected value that her phone could hold, which is 2,000. Remember, this is an absolute value because the distance is going to be the same on either side, could vary or be off by as much as 250, so equals 250 phones or 250 songs. Down here, they just show both cases. So remember, every time the absolute value is by itself, we can have it equal to a positive or a negative version of that solution, and we have it solved for both. So when we solve the right-hand side and we add 2,000 to both sides, we see that we end up with X could be 2,250 songs. Now on the right-hand side, we're adding 2,000 again, but we're adding it to this negative. So this is the under. So we have over 250 and under 250 from the expected value. And we end up with 1,750 songs. The solution set, remember, from small to big, is going to be 1,750 to 2,250. The maximum and minimum number of songs are, and of course they wrote those same numbers right there. Go ahead and pause the video and see if you can do the check here. Okay, for this skydiving one, it says it takes approximately 6 minutes for a diver or skydiver to land after she jumps out of a plane. So that's 6 minutes to land. That approximately, that sounds like some sort of expected value. So I'd write down expect. So you expect to land about 6 minutes. Because remember the formula that's up here. We have actual minus expected equals some kind of tolerance, difference, or error in our calculation. So that sounds like an expected value. Give or take 30 seconds, that sounds like the error. So over 30 or under 30 from the expected value. What is the range of time in seconds it could take the skydiver to land? Now, some of you could probably answer this without actually writing the equation, but you want to get in the habit of writing the equation. So if we have actual minus expected value, the absolute value that will equal let's go with D for difference. Well, it looks like the difference, the over-under is 30 seconds. 30 seconds. How long is it going to take her to actually come to the ground after jumping out? We don't know. So her actual value, we're going to just leave that as A, her actual value. But her expected value, so bring down a minus, her expected value, we do know that she expects to be 6 minutes after jumping out, landing on the ground. The problem is our answer over here, our difference is in seconds, but our expected value is in minutes. So in order to do this correctly, you're going to have to convert the larger unit, which is minutes, into seconds. So 6 minutes times 60 seconds is going to give us 360 expected seconds. So in our expected value, we're going to put 360. So actual time that she takes to get down to the ground minus 360 seconds should be no more than 30 seconds above or below that amount. So how do we solve it? We write two equations. We write one with the output possibly equaling 30, because remember, this expression in here could either equal 30 or negative 30, so I have to write two equations. So the other one is a minus 360 equals negative 30. And then we solve both of them. So we're going to add 360 to both sides on this one. So a equals 390 seconds. And we're going to add, oh, I forgot my 0. There we go. We're going to add 360 to both sides over here as well. So this 0 is out, so we have a equals 330 seconds. Now they do want to split the answer in this form. So we got the low one is going to be 330 seconds all the way up to 390 seconds. So this could be 60 seconds off. Example 4, we want to write an absolute value equation. When we write an absolute value equation, especially from a number line like we got here, or if I just give you two numbers and say write that as an absolute value equation, got to remember what the general equation looks like. So absolute value of x minus some expected or central value is going to equal some kind of difference. So all we got to do is figure out the expected value and the difference, and x is always going to be our variable. Remember, these are distance calculations. So we want to know the distance between these two will be this amount over here, which is d. So if I have 17 as one number and 27 is another number, these two numbers have to be the same distance from our expected value. Remember, it's an over and under calculation. Okay, so if we look at these two numbers, 17 and 27, we want to find the point that's halfway between them, and that will give us the same distance on either side. So if we average them, 27 plus 17 will give us 44. Now that's two numbers I added up, so divide by 2, and we end up with 22. So our expected value here would be 22, which is right in the middle. So now we already know that we have an equation of x minus an expected value of 22. And what's the distance or difference over here? Well, how far is it from this point to the expected value? And how far is it from this point to the expected value? And you can see in both directions, whether you go from 22 up to 27, that's up 5. If you go 22 down to 17, that's down 5. So the difference is going to be 5 in either case. So our final equation would be x equals absolute value of x minus 22 equals 5. Okay, so let's go ahead and check this one. It says label each graph with the correct equation. Okay, so if we look at the first one, we have -2 and 4, and the number that is halfway between the two, remember we're going to average them. So 4 plus a -2 is going to give me a 2, and 2 divided by 2 is 1. So the number that's halfway between them is a 1. Now it's on the positive 1 side. We don't want to put +1. Remember, these are distance calculations, so it's always a minus. The only way you can have a plus inside like you have here is to have a minus a negative, which causes a positive. So this is a distance of 3 on this side and a distance of 3 on this side from the central number of 1, which we can clearly see is this one right here. So absolute value of x minus 1 equals 3. Okay, for this next one, I can average, or I can just kind of eyeball it here. Want to find the midpoint. And let's see, I'm going to go ahead and average them. 8 plus the -2 will give me 6. Half of that is 3. So I'm looking for a value of 3 as the midpoint. And that's going to be a -3, not a +3, because remember, the original problem is always in minus. It's the difference. So minus a 3 versus minus a -3. So the distance here, though, is, we can calculate, so from 3 to 8 is 5. And the distance from -2 to 3 is also 5. So now we have this one up here, which is absolute value of x minus 3 is equal to 5. The next one down, we have a 7 and a -5. So if I add them up, I get a 2, and of course the average of 2 would be 1. So the midpoint should be 1. Midpoint is 1. I just got to calculate the distance. 1 over to 7 is a difference of 6. And -5 over to 1 is also a distance of 6. So I have x minus 1 equals 6. So absolute value of x minus 1 equals 6. And by default, the last one should work, but let's go ahead and test and see. Based on the way this one looks, it says plus 3. Remember, it's supposed to be a minus, so minus must be minus a negative here. So minus a negative, I'm looking for a -3 in the middle and a distance of 6. So let's see, -3 is right here. And if I calculate from -3 back to -9, that distance is 6. And from -3 up to 3, that distance is also 6. So yes, that does match. So absolute value of x plus 3 equals 6 plus